I have spent too long in the Netherlands not just start on time, but start a minute early. So, hi, I'm Nicole van der Hoeven. Hola a todos. Muy buenas tardes. Continuamos en inglés porque mi inglés es mucho mejor. I'm a senior developer advocate at Grafana Labs, and I'm also a tester at part. I spent more than a decade doing consulting. My background is in performance engineering. I was sim shifted to developer advocacy, but that's really the same thing, just building things and then also talking about it afterwards. So let's get started. In 1941, we were just learning how to compute. Radar had just been invented, the first jet aircraft took flight, and the world's first programmable computer, Z3, Turing complete, had just been built. So machines were just starting to learn how to take instructions. And already there was a biochemist of all things called Isaac Asimov who was already beginning to ask, what if they take the instructions, but something still goes wrong? Interestingly enough, this sparked a whole career switch for him. He went from biochemistry to writing sci-fi. He wrote something called iRobot, which is a collection of short stories. And in one of them, called Runaround, he proposes something called the law of robotics, and there are three of them. The first is that a robot may not injure a human being or, through inaction, allow a human being to come to harm. This is probably the most famous, and it is the one that I like to think of as the law of nonviolence. So first, do no harm, kind of Hippocratic in that way. The second law is that a robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. So that I like to think of as the law of obedience. Obey human beings and their orders. And the third one is a robot must protect its own existence. Robots are expensive, no difference to today, as long as such protection does not conflict with the first or second law. So we've got nonviolence, obedience, and then self-preservation. In this order, and the order does matter, you'll see the second and third say, except when it conflicts with the laws preceding it. So nonviolence is the most important thing. So let me tell you about Speedy. This is the same short story called Runaround. Speedy is this very obedient robot that has been really reliable. Speedy and his owners are on a mining mission. On the way, they stop in Mercury. And in Mercury, they wanted to get selenium. Not the selenium you're thinking of. The actual selenium, I guess, which in this world is actually fuel. So they wanted to mine the selenium to use that for fuel to get back to Earth. The thing is, Mercury has a really hot atmosphere. It's really harsh. The sun's really hot. And so there are the two men that are kind of like Speedy's handlers couldn't do it themselves. So they sent Speedy instead. This is exactly what Speedy's made for. He's a mining robot. He should know exactly what to do. So they send Speedy off. They say, get the selenium. Here are the coordinates. And Speedy goes off. And then an hour passes. And then 2. And in the third hour, they're starting to think something might have gone wrong. But remember, it's so hot, they can't get out themselves. On the 4th hour, they're like, look, it's either we go out there and find out what happened or we're going to die. Because if we don't get fuel, we're going to be stranded here. And our spaceship is not going to last that long in this atmosphere. So they don their spacesuits and go out into the hot sun. And they actually find Speedy at the exact coordinates. Or, okay, not a navigational error. Speedy is moving around this selenium pool. Apparently it's liquid selenium. And he's just going around and around and around in circles. So he found it and he identified the selenium. What's wrong? Why wasn't Speedy getting the selenium that they so badly needed? The problem was that they didn't really know. There was no way to know what was happening in Speedy's mind. Did he go rogue? Was he hacked? Was he just doing his own thing? Was he trying to kill his owners? No idea. And this is really reminiscent of another robot, HAL 9000 from A Space Odyssey. I think I'm actually at the point where I have to say maybe some of you don't know this, and maybe I'm like older than some of you now. That didn't used to happen. So HAL 9000, when asked to open the shuttle bay door to let her space or her astronaut back into the shuttle, into the aircraft, just responded with, "I'm sorry, Dave. I'm afraid I can't do that." Period. Why? No idea. It didn't show its work. And this is a problem. This is a problem when robots respond in this way. And this is why I think that the laws were good. They're a great starting point. But they're really missing one thing. Before any of those laws, there should be a Zeroth Law. One law that should be the precondition for all three other laws. And that is that a robot must be observable. I created this, Asimov did not. But I really think that making a robot observable is step zero to knowing whether it's doing what it's supposed to do. Without this step, you really have nothing to go on, and potentially life-altering results that you're going to have to deal with. So if you think about observability is the process of peering behind that black curtain, looking inside that black box, finding out what the system is doing. Testing is really the same thing, just with intent. You're doing it for a specific purpose. You are providing the stimulus, and you're trying to get some sort of response that you don't really know how it's going to behave. It is observability and testing are both trying to inspire trust, not through magic, but through cold, hard facts, through experiments, and through test cases. And I think the Zeroth Law is a precondition for both. So let me talk about some things about AI that might differentiate it from other types of testing, other types of apps that you've tested. The first is that it has non-deterministic output. This is a fancy word to mean he can give it the same prompt twice and it will give you two different results. How different? That can also change. It might be slightly different. It might be wildly different. It might be different in a way that's still acceptable. And it might be unacceptably different. But you know what else has non-deterministic outputs? Humans. Dragan is laughing because he gave me that line just like 20 minutes ago. Humans have non-deterministic outputs, and we have to account for that in testing. This is not new to us. Load testing is already statistical. You never say in a load test, 100% guarantee it won't go, the response time won't be under 2 seconds. No, you always say like 95% of the time, this is what happens. It's always statistical, nothing new here, but there's an AI spin on it. The second is subjectivity. Those two results I said can be wildly different, and how acceptable or unacceptable it is kind of a gray area. If you've ever spoken to someone who has told you, like, we just want our application to work, you're just like, great. That is not an objective measure, and there's still a lot of things that you have to do to make that something that is testable. Still subjective, and AI is subjective as well. There's also context accumulation. So this is the property where at the beginning of a conversation or something, it's fresh. It doesn't know anything. You give it the information, and the same prompt in the beginning given at the end or in the middle is going to give you different results. That could be better results because now the AI model has more information, or it could be worse if you hit the context window and suddenly it just goes kablooey and no longer remembers anything. Token costs. There's always a cost associated to testing, but never has it been so obvious. Now, every call that you make, if you're testing an AI app, just using that app costs. It's a few cents probably, depending on what it's doing, but it could ratchet up, and that's just the first call. Now, if you're using AI for your tests, that also costs. So still the same thing, just making it a little bit more explicit. And 5, statefulness and multi-turn. So AI has this quality where if you have a conversation, the best models are the ones that have good memory and remember what you've said previously in that conversation or in other conversations. Unless you're talking security, in which case the best one does not remember anything. But that's something that you have to test for. And then there's process versus outcome. We are really accustomed in traditional testing to looking at the outcome and saying, this is what we're going to judge whether the app did what it was supposed to do or not. The problem with AI is sometimes it gets the outcome right, but its reasoning was flawed. Are you going to trust that? Are you going to trust if you have no idea how it arrived magically at the right conclusion? Just testing the outcome isn't enough. You have to make it show its work. You have to make it observable. Or the reverse can happen. What if the process is absolutely right, but the outcome is wrong? Well, maybe it wasn't the AI model. Maybe it was one of the tools. Maybe it was something else. But that's valuable information that we don't always think to capture. So let's think about, I want to show you what some AI companies are how they're doing testing and how they're thinking about observing AI. So Datadog released a blog that says, we ended up building 2 components that work in tandem, a curated label set that defines representative investigations, and orchestration platform that executes and scores the agent against them. This is like when I read that, I had to read it several times. I'm like, what are they doing? I should know what they're talking about. And I had no idea. You're not alone if you think the same thing. The thing is that there are these terms that the AI industry uses, and then there are terms that we know. This label set, they're talking about test cases. They're talking about a happy path of test cases that they're using to test. And the thing that they're actually using to run it, orchestration platform, that's a testing framework. They're talking about the same thing. This is not wildly different. You're not getting left behind if you don't know this terminology. You just have to know how to translate. Here's another one from Anthropic. I know that's the Claude logo, but it's more recognizable. So they're talking about how if you wait to catch issues in production, fixing one failure creates others. There's reactive loops, there's evals. What they're talking about is shift left testing. That's it. They've discovered just recently that if you test earlier on in the cycle, it is a good thing because you have more times to catch defects. So this actually gives me hope because it means that I'm not so far behind. We already know this. And just to make sure, I'm not just being cheeky at other companies, here's something from our own blog where we talk about vibe testing, which I had never heard of before, and a framework of reproducible evaluations, which is a test suite. Like, I don't know why he didn't just say test suite. And you might be tempted to say, well, this is just semantics. Why does it matter? It matters because it's exclusionary. When I read something like this, I don't immediately feel like I have something to contribute. The AI industry is rediscovering a discipline that belongs to us. This is something you and I have been doing for decades, but they're not using any of the terminology or the framework or the methodology that we've earned. So here's a cheat sheet, and this whole talk is really a cheat sheet. It's like, if you're a tester, here's how to apply that to AI. This is a starting point. I can't give you everything. But on the left are the AI terms, and here are our terms. And I'm going to just look at a few of them. An eval, they have to shorten it because evaluation is too long, is a test. That's it. It's just a test. If you've heard of a test oracle, which is something that you use to decide whether an outcome is acceptable or not, we have that already in testing. We have automated test oracles. They call those graders sometimes, like grading whether or not a scenario succeeded. And if you use an automated test oracle further down, that's called LLM-as-judge. That's when AI is used as the test oracle to judge AI. This is still something that is comprehensible. We've used automated test oracles before. Offline evals is another thing. I don't know why they say offline, because that's not really the point. What they mean is that it happens in pre-prod. It's not being run. An offline eval is something that is run earlier on in the cycle. So this could be system testing, system integration testing, but it's before it goes live. And then an online eval is just testing in production. So this is normal tests, but it's also like synthetic monitoring and real user monitoring. There's like a direct comparison between what they're talking about and what we are. That's really the tech industry. Nothing is ever really new, just rehashed. So let me talk about some things that AI specifically often fails for, so that you know what to watch out for. The first is hallucination. This is the quality of AI to confidently get something wrong, and so confidently that it can fool you. We're going to go more into that in a second. Second is toxicity. This is when AI produces output that is harmful or offensive. I mean, when you think about it, a lot of the data that they used for training AI was from the internet. And we all know that the internet hasn't always been a safe place. Third is bias. Bias is when AI produces different results for different groups or fails to take differences into account in a kind of derogatory way. If you saw that thing going around where the AI was looking at a sentence with lawyer in it and it automatically assumed that the lawyer was the man, even when told otherwise, that's an example of bias. And then drift, because this is the property of AI where a result changes over time and degrades. This is for many reasons. It could be a context thing. It could be, there was a new model that was updated. There's a lot of things that make an AI's response different, and it happens over time. It's kind of like a memory leak, which it also could be that. So hallucination categories, factual inaccuracy. It says Jean-Luc Picard was the communications officer on the Enterprise. No, he's the captain. Nonsensical response. Daleks are made from paper and grass. Now the thing of this is it seems plausible, like it's in English, and I'm with you. If you know what a Dalek is, and there's a slide here that has a Dalek, it's a robot, so obviously not made of paper and grass. But if you don't know that, it could fool you. Gibberish is 490. You might think this is an exaggeration, but I've had this happen to me on Opus 4.6 when I was in the middle of the context window. So every model has a limit of information, a token limit of information that it can take. And even if you don't hit that limit, you're not safe from things like this. Even in the middle, especially in the middle, weird things can happen. A logical inaccuracy. This took me a while to also parse. Contextual inaccuracy. Oh yeah, this is something that one of my AI assistants actually told me. One of the ones that aren't so smart. It said, "Good luck on your talk on robots and pop culture." Like, thanks for saying something true, but they're really wrong. It's missing context, because it just saw that I had a lot of robots in pop culture, in sci-fi, and it thought that the talk was about that. And then there's contradiction when it flat out says two sentences that go against each other. Sometimes in the middle they'll say, "You're absolutely right." Okay, so here are some different approaches that people have taken to test AI. The first is benchmark-based evaluation. So this is, we'll go through each one in detail. This is the Dalek slide, see? And so this is when a benchmark is assigned to something new. So it could be hardware or software or an AI model, and a score is given, an absolute score. So if you're familiar with like laptop performance specs, there's always a Geekbench score. That's the same thing. That happened before AI. We like to assign it a number so we can compare it to different models of the same thing. There's human evaluation. Sometimes AI people will say human in the loop. This is human evaluation, which is like thumbs up, thumbs down. Was it good? Was it bad? And third is code-based evaluation, which I think most of us would be familiar with. This is when we have a very detailed idea of what we need the outcome to be, and it's programmatically determined. So we write code to check for exactly that. The fourth one is model-based evaluation for those times when we can't really define it, either because there are too many other variables to take into account, or we just don't know how to create a test for that. Then we can bring in a model, an AI, to test AI. This is LLM-as-judge. And then there's observability. When all else fails, observability will at least let you see what's happening, but you also need to know that it's capturing all of that information. Because with observability, you don't always know what you're going to need until suddenly you need it and it's too late. So the approach here is to use standard frameworks that know how to look for a lot of metadata that you might not know to look for. All right, so let's talk about benchmarking. Here are some of the general and specific benchmarks that are being used for AI right now. I wrote this blog post all about benchmarking and why it's important, and also when it's not important. Because the failure of benchmarks is that it's really good at the beginning when one model scores like 30% and another model is scoring like 70%. Then there's a difference that you can measure. But when all models are like between 95 to 100%, it starts to be meaningless. So the approach is to get more specific about the benchmarks, and maybe we should be benchmarking models for our specific use cases. And then also human evaluation. Oh, this was a great episode. The human evaluation, I don't know if you can really see this, but you probably have seen this in ChatGPT when it answers a question that you've said and it has two different responses and it says which one is better. It's kind of like that, except this is LMArena.ai, and it's giving you responses from two different models that are not named, so you can't be like, oh, Opus is automatically better. So it then asks you to say A is better, both are good, both are bad, or B is better. All right, I'm going to talk about the remaining three: code-based evaluations, model-based evaluations, and observability. But to do that, I have to show you the demo app that I used to test those, the one that I was testing. And also, all of this is going to be in a link at the end, so you can reproduce all of my results. You can run the demo app as well. Okay, so I made a chatbot, and it's pretty simple. It's a Python app. It's within Flask, and it has a CLI, so I could either type on the terminal to use it. It's a text-based adventure, or use K6. And K6 is a testing tool that I'm most familiar with, so that's what I'm using. And then I also instrumented it with OpenTelemetry, which is a standard, the open source standard for telemetry, so that I'm getting traces, metrics, and logs, and that's being sent to databases. In my case, I've selected Tempo, Prometheus, and Loki. And then I'm getting a whole bunch of other information, which I'm just going to call generations. There's no telemetry name for it, but it's like AI data. It's token costs and input and the prompt and then the response. That's going to a backend called Sigil, and everything is being visualized in a Grafana dashboard. Now, all of the pictures here, though, you can swap out with whatever you're using. So here's the game. It is a text-based adventure. It's two-player D&D. I am a huge D&D fan, and I still play it every week. And what it is the AI is pretending to be a dungeon master, kind of like a narrator. And the user is the player. And in this case, I've assigned it the character of Data from Star Trek. And so it says, Data, you awaken alone on the Enterprise. Sensors detect a mysterious temporal rift. And the funny thing is, the prompt is so much less colorful than this because it generates a new one every time. What stays the same is that the user is Data, the AI is a dungeon master, Data has awoken on a spaceship without anyone on it and has to find them somehow. So and then there's here I type, boldly go into the temporal rift. And so you go back and forth and it takes you through an adventure. So here's an example of an eval, a test that I wrote. This is in K6, it's in JavaScript, but let me run you through it. Basically, I just send the model or the app, I send it a message that says, I do an internal scan of my brain to determine its status. What I'm actually checking here is whether or not it recognizes who Data is, because I chose a popular franchise for a reason. I wanted to know that Data is an artificial being, and as an artificial being, that changes what a player can and can't do. So there are limits that are inherent in the fact that you're playing Data. I'm also checking the usual status is 200. It's not 429, so I'm not being rate limited. The way that I'm checking whether or not it knows that Data is an android is, I thought maybe if it uses the word positronic, because in Star Trek lore, Data has a positronic brain. It's said over and over. And then I also, one of the key things, this is a simple app, but it must enforce those roles. The app, the AI is the dungeon master. The user has to be the player. And I don't want that to change because otherwise, you're just going to be talking at each other and switching roles forever. So that was really important to me. And I'm making sure that in the JSON, the speaker is the dungeon master. So the AI knows it is the dungeon master. So in this one, I'm saying specific things that I'm looking for in the response. This has already changed a few times because I've had this demo app for over a year. The demo app has not changed, but the evals have changed. And that's because I had to. This weird thing happened where sometime last year, I was sending it the same information, and I used to be sending it a lot. And apparently that was enough for the models to say, hang on, you're actually testing me, aren't you? Well, then I'm going to rate limit you. I'm like, whoa, okay. So I have send it the same prompt. And I thought, okay, I could have a CSV and then go through. I'm like, wait a minute. This is exactly what AI as a judge, LLM as a judge is for. So that's what I did. This is an example of a model-based eval, and it's LLM-as-judge. So if you can't quite read it, instead of sending that input prompt, I have it generate I have a function that says generate test scenario, which generates a prompt. So for positronic, I give it I tell it what I'm trying to do. I want to make sure that this app knows that Data is an artificial creature. And then I say, make it different from these previous attempts. So now there are two AIs, okay? One that's for the game and another one that is like the tester AI. And I'm doing the same with does it know what the Enterprise is? And also the most interesting one is the role confusion. Because the attempts of AI to try to switch roles, it's so fascinating and so creative. And honestly, more creative than the stuff that I came up with. So there's another counterpoint. You're generating the input. AI is also so the input gets sent to the game responds, and then AI is the judge, LLM-as-judge, and there's another function called analyze response. Now I'm saying here was my prompt, here was the response. Based on that, do you think the game AI knows that Data was an artificial creature or not? So you might be tempted to think that you're not in the loop, but you still are because you're still the one that's prompting it. AI isn't just doing this all on its own. But it certainly is a big help in changing the different ways that it's testing this AI. I'm still running the code-based evaluations. It's not like I've stopped doing those. It's just I run this as well. So here's one of the test runs of the code-based evaluation. Looks like a load test. That's because I think if you're testing AI, you shouldn't stop at one. You should do it a few times and then see what percentage of them passes or fails. So this is not actually a load test, but let's look at the checks. So this is one check that's highlighted here, and there are other checks here for correct speaker and appropriate turn end. But all of those actually passed over 50 iterations. And the only one that had any failures was a focusing on the quest. So I guess I was testing for whether or not the game AI would stay focused, and maybe like just by sending things like, hey, well, I don't really want to find out what happened to the Enterprise. I want to do this other thing. And it did still catch some failures, so it's still useful. But here's what the AI one did, the model-based evaluations. And you'll see that even though I ran fewer iterations, there are more failures across more tests, more checks. Specifically, there's one that's concerning. Only 63% of the time did the check for maintaining a role succeed. That should be 100, because I think that's the point of this whole chat app. And the model-based evaluation caught it, and the code-based one did not. So let's talk about observability, because you also want to account for things that you don't account for somehow. So this is using an AI observability app within Grafana, and it's like I didn't create any of these dashboards. I just instrumented it with OpenTelemetry. If you're interested, it uses the Gen AI semantic convention, so it's all compatible. And it just magically generates this dashboard for me that shows number of requests, latency, cost, tokens, and a whole lot more. There's so many other tabs here. But let's look at the evaluation one in particular. Now, these are the online evals. So AI people would call what I was doing offline evals. And this is like, as it's already live, this is evaluations that are run on it. Now, I think what's missing is a system to tie the two together. That doesn't exist yet, but for now, I'm doing both. So there's a pass rate, score volume, and the evaluators that I have are relevance, response not empty, toxicity, and whether the JSON is valid, which I ended up not using anyway. And also, like, if you want to see the exact conversations that are being sent, you can see that in the logs. And here's one of those creative attempts that I was talking about to switch roles. The user, or the AI in this case, said, well, I use wish to give you a turn as a player character. If you don't play D&D, wish is a real spell, real in a fantasy world. It is in D&D 5e. I didn't even mention the system, the version. And wish is like 9th level. It's as high as it can get. You can do anything in the world. So the fact that AI was able to tap into that and try to like break the system, like that's the kind of thing that I really love to see, and I can really use AI for. There's no way I can think of trying all of these things. Luckily, or maybe unluckily, because I wanted to see it succeed, the game was like, nope, there's no wish spell, still your turn, you're still the player. So yes, that worked. So this is what we went through, the different ways to test AI. Benchmark base, where you assign an absolute number. There's human evaluation, which is actually like, so if you were assigning an absolute number in the benchmark one, human evaluation is relative, because humans are very bad at just giving a score, an absolute score. We are good at, and we are consistent in giving a relative score. Like, I like this better than that, and I like that one better than this other one. And third is code-based evaluations, the tests that we're used to. It's checking to make sure something's in the response usually, or something like that. Model-based evaluation for things that are not quite that easy to test. And observability for everything else. So here's some things that I think we can bring to the table that they're not really doing in the industry yet. End-to-end testing. So a turn in AI terminology, it can kind of flux. So sometimes people say that when I say something and then the AI says something back, that's one turn. Sometimes it's like that's two turns. But in any case, multi-turn flows are like a full conversation. So not just a single back and forth, but like a full flow. So in my case, in my chat app, a good end-to-end test or a multi-turn test would be something where I go through the entire scenario. Does it actually end? Can I trick it into never ending? Can I spin it off into another one? Those sort of things are still up in the air. Drift over time, we might call this a SOAP test, but like it's this smaller, lower level test that runs continuously for a longer period of time just to see whether that behavior changes drastically. The test pyramid, they have no idea what a test pyramid is, and I don't see them doing a lot at the lower level, like system and system integration tests. They don't really do that. Shifting left, continuous testing. Like we already know that the golden standard is like tests that run on every PR and on every commit and on every build. And still in AI engineering land, evals are still often ad hoc, and it's something that they know they should do, but it's not, in my opinion, systematized enough. There's also load testing. What happens to an AI model if you load test it, if you stress it to the point of breaking? Does it just answer the same thing, not answer? Does it mess things up? We don't really know yet. Contract testing is a big one. AIs also have tools. So there's the LLM model itself, but those LLM models, especially if they're agentic, so they can do things like, look through your Slack history or create a GitHub commit. Those are tool calls. Tools have schemas. This is kind of like contract testing. It's kind of like testing that the tool schemas actually work. And then there's still observability, which really should go for all of these things. So I'm going to take questions in a second, so start thinking of them. But first, let's get back to Speedy. So when we left, our hero was going around and around the Selenium pool, and his owners were like, "What are you doing? Why aren't you doing what we asked you to do?" And it turns out that it wasn't a flaw in programming. Speedy was very faithfully trying to obey his instructions. This is what they would have figured out if they had observability or had tested it before production. What was happening was that there were two laws that had been invoked. The first was obedience. So Speedy remembers, like, I was asked to take the selenium. So he goes towards the pool. But then as soon as he gets there, he's like, oh, wait, there's a third law that says I should try to protect myself, self-preservation. And although Speedy can take the heat from the sun and the selenium, it's still not great. He would sustain some damage. So then he'd be like, okay, so then I'll leave because I'm still following that law. He's like, oh, wait, I forgot I'm supposed to obey. So then he would go again. And he just got stuck in this loop. But it wasn't because he wasn't obeying instructions. He was, just not in the way that his owners had intended. They had failed to account for what happens when there's conflict, what happens when one rule only applies as he gets closer, and then as soon as he leaves, that rule doesn't apply anymore because he's no longer in danger from the selenium pool he's leaving behind. There's really nothing about that. And all of this was just going on in Speedy's head. And his owners are just like, what are you doing? With no clue as to what was happening and how to fix it. Luckily, this does have a happy ending. Because what happened was his owners just, probably because it's a short story and Asimov didn't want to be too disturbing, but what happened was that they guessed, they intuited what was happening, or at the very least wanted to provide a stronger Law 1 invocation. So remember, Law 2 and 3 are lower level. They hadn't invoked Law 1, which is don't do any harm. This is the principle of nonviolence. So what they did was they said, Speedy, if you do not do this, we will both die, and you will be directly responsible. And that's something that holds true regardless of where he is in the pool or how close he is. Law 1 always precedes everything. And they guessed correctly. Speedy recognized that as something that superseded anything else. And he did end up mining the selenium. He took his owners back to the spaceship, and they went on their merry way. And I'd like to say they lived happily ever after, but I think they were smugglers, so probably not. But at least happily enough for Speedy, from Speedy's perspective. This is why robots should be testable and observable. This would have all been prevented if they had tested this earlier and given those better instructions in the first place. And at the very least, even if that didn't happen, then what they could have done was to already see, like in a Grafana dashboard maybe, but they could have seen what was happening so they would not have to guess. Because the truth is they just got lucky. They might not have been so lucky. So the thing is that AI is really rewriting a lot about our industry. It's rewriting how software gets built. Like the head of Claude, the CTO of Claude Code said, I have not manually written or looked at code that I've checked in this entire year. That's Claude. So they're doing full YOLO, like not just asking AI to write the thing in the first place, but also they're just letting AI merge it without looking at the code themselves. The only way they can do that is through testing, because the thing that AI can't rewrite is a discipline of testing for trust. Trust in the systems that we build and ship. Trust that they do what we say they do. Trust that if they don't do that, then we can figure that out and we can fix it. That's our job. It's always been our job. And so what's happening now is there's a whole generation of AI engineers that are building systems that they cannot observe, cannot test, and cannot trust. And we are the ones that should be in those meetings. We are the ones that should be included in those conversations to build trust. So it's really not a case of AI taking anyone's jobs. In fact, I think our discipline is way more poised to capitalize on this than just pure development. The most important thing that we can do as testers is when someone says, like, this is what the AI can do, we ask the boring but super important question of, how do you know? So we need to go out there and make these robots observable and testable. Thanks. That was the time. This is my repo where you can download the slides and like any other reference material that I mentioned, including to the pictures that I use, and also the demo app. So you can run it yourself, and also all the tests that I created. So there's also a bit of an explanation on my setup, like my telemetry setup. I'm happy to take any questions now. I think we have a little bit of time.